Before I get into it, please remember to like and subscribe. Smash that like button, subscribe to my channel, and turn your notifications on. I'm actually starting a new series next week called What I Learned in Grad School This Week, and I'm going to grad school so you don't have to. Just kidding though, you might actually want to go. Hello again and welcome to another video. This video I want to help you guys learn to code. So there's a lot of good ways to learn to code and there's a lot of great courses and resources online, but the best way to learn to code is actually by doing your own projects. Now it's good to start off by taking an online course so you kind of understand the basics, so you learn some of the basic syntaxes, but courses are really very clean data sets that you'll be working with. And the process to build an actual model in the real world is never that easy as they make it into a course. So it's a lot easier to learn by doing, and you learn by doing when you're actually doing a project. And when you're working as a data scientist, most of the work you'll be doing is project based. So you'll have a project, you'll have a start date and pretty much an expected completion date. So doing your own projects gets you into the rhythm of doing work on a project basis. It's not the same thing. It's not like you'll come in and start doing the same thing every single day. You'll have one project that might take a few months and then that'll end, and then you might be doing another project that's completely different with completely different data that'll do in another few months, and then repeat and repeat and repeat. First off, and something very underlooked when people talk about data science is projects can be fun, and they should be fun. If you're not enjoying doing the project, maybe this isn't the right field for you. But my first projects were actually doing sports analytics, which is something that I love. As you can see right there, I'm a big sports guy. I still have my high school state championship ring. Do you want to see it? Teaching high school. Not even joking, I can't get this off. Holy fuck. Holy. I actually can't get this. Okay, got it. So my first project was actually comparing Michael Jordan, LeBron, and Kobe to each other. And looking back at it, this is a project that it would not have shocked the world. I pretty much just took basic career stats, showed a visualization, and pretty much put it up on my GitHub for people to see. And it wasn't even predictive, so it wasn't even a full data science project, but it really taught me how to get data, manipulate the data, and visualize the data, and most importantly, communicate the insights from my findings. So it should be enjoyable to you. You should definitely work with data that you are familiar with and is enjoyable and interesting to you. It'll just make it a lot more fun, and it won't feel like a burden. It'll be something that you're going to be doing in your free time, so it'll actually be enjoyable and won't just feel like you're bogged down and it's another task that you're never going to get accomplished. So the first thing you're going to do in your project is you're going to learn how to get the data. And a lot of people get data by web scraping it from online. And this is something that I myself need to get better at because I really don't web scrape that much. If I do web scrape, it's usually with code that somebody else has written. But if you already have a lot of coding background and you want to start learning how to web scrape, that's really going to help you a lot in your own personal projects. And if you don't know how to web scrape, you can always get data sets from Kaggle.com. They have thousands and thousands of data sets up there that all have the descriptions of the data set, they have when they were collected, and they have descriptions of every field for the data set. So it's really cool and it's very useful. You can find exactly what you're looking for over there. And if worse comes to worse, you could always just search Google. Now, once you have your data, you're going to have to manipulate and clean the data for the first time. So what you're going to learn is if you're using Python, you're going to start using the pandas package, and you're going to have to rename columns, delete columns, or reformat the data in a way that's clean and presentable. And you're also going to have to decide what you're going to have to do with null values and missing data, which is a lot of what data scientists have to do, with what any data professional is going to have to do. And after you're manipulating the data and cleaning it for the first time, you're going to do exploratory data analysis, which is very important and is actually probably the most skipped step in data science because people want to go straight from the data cleaning to the data modeling, which is not good practice because in exploratory data analysis, you need to explore the relationships in the data. So the easiest way to do this is just by creating a bunch of visuals. For one field, create a bunch of histograms, see the frequency of the data. Get some counts in certain columns, see what's the most frequently occurring thing, get some sums and averages, aggregate the data, create summary tables, decide which relationships in the variables you would want to see. And also, of course, pick your target variable, decide what you're going to be predicting. Next up, this second data cleaning. Now, I say second data cleaning because once you have the data in a format ready for visualizations, you're going to have to clean it again to get the data in a specific format for your modeling. So you're going to have to decide which model you're going to want to use, and this is very dependent on what you're actually predicting. And once you figure out what model you're actually going to use, you're going to have to do a lot more data pre-processing steps and data manipulation steps to this data that you already thought was clean. For instance, most models, with the exception of decision trees, can't handle categorical data. So you're going to have to decide what you want to do with categorical data. And you're going to learn about label encoding and one-hot encoding. And you're going to have to decide which one you want to use. So that's another data pre-processing step. And also, if you're using a lot of algorithms, like if you're using a neural network, you're going to want to standardize or normalize the data, which is pretty much rescaling all the input data so that it's on the same scale, so that the model can learn from the data better. So you're going to learn about the difference between standardizing and normalizing and which one is better for your model. And then after that, you're going to have to split up the model again into your training set and your testing set. And maybe even your validation set, that's a very good practice to have. Start using validation sets too. And you're going to have to learn the syntax to split your data into the X train and the Y train, which is very easy in Python, maybe a little more difficult in R, but it's just good practice to have. And once you understand what the code looks like for this, it's very similar for every single project. So it's great to be able to learn to do that on your own. Now, what I just talked about is 80% of your project. And it's 80% of your job as being a data scientist. So the last 20% is actually what everybody always wants to jump right into. It's the modeling component. So now that you have your data formatted, you can actually choose which model and test and train and experiment with different types of models. So if you're doing some sort of classification, start off with a logistic regression, start off with a random forest or a decision tree, something that is very fundamental and will teach you a lot about modeling. And if you're using a regression, start off with a linear regression. You can also use a random forest regressor. You can use boosting models. You can use SVMs for either classification or regression. There's a lot of different shallow algorithms you should experiment with. And if you want to, go ahead and try using a neural network, try using multi-layer perceptron maybe in the scikit-learn package. Once the data has been pre-processed and is standardized, normalized, you've taken care of categoricals and null, you won't really need to change it much from model to model. You might have to, but that's something that you're going to learn and find out with the different models you're testing out. But it's going to be fun and you're going to learn a lot. And when you're training and testing your models, you're going to learn the practicality of some models. This is why I said learn shallow algorithms before using neural networks, because they're just more practical in most cases, especially if you're running things locally. You're going to quickly learn that the runtime for a lot of neural nets is very, very long, especially if you're using grid search. It's ridiculous. But learn a lot about the shallow algorithms first, learn which one are performing the best in each situation. And since you've already done the data pre-processing, you might understand quickly which ones are just easier and faster to use, like random forest. You actually don't even need to format the categorical values. They can actually handle missing data also, so it's a lot easier to implement them than something else. So you'll learn that, and you'll also learn about parameter tuning, because models all have different parameters. You'll learn something that you change a lot in a random forest is the number of estimators. And then you'll start using a boosting model, and you'll see that number of estimators is also a parameter that you change in boosting models. And then you'll look back and realize that boosting models are really optimizing decision trees. And that's why they have similar parameters. And then you'll look at other things like neural nets or SVMs or other regression models and see that they have completely different parameters. So you'll learn about the different parameters, and that'll help you understand how each modeling technique works. And then now, once you're testing out the different models, the way to test them out is you have to score them against each other, of course. So learn how to score classification models, learn about accuracy, precision, recall, F1 score, things like that, true positive, false positive. You're going to learn about things like that. And as far as regressions, you're going to learn about R score, mean squared error, mean absolute percent error, the different ways to score a model. Learn which one is the best representation of how your model is doing. And there's actually no number one or best scoring method for each model. There's methods that people prefer, like me, For regression, I like using mean absolute percent error. That's just me. But there's a lot of different ones. A lot of people use R squared. But it really is something that you can mess around with and decide which one you like working with the best. So then you'll create your predictions. You'll have a fun time. Me, so one of the models I'm doing is I'm predicting the scores of every NFL game for the NFL playoffs for this year. It's very fun. I love doing it. And also definitely put it up on GitHub. Let people see it. Let people see your work. Even if you don't think it's the best, promise me, my projects were not the best at all when I was first starting. But having them on GitHub gives employers and people a chance to see your work. And just having a GitHub makes you look a lot better as an applicant. It really does. You know, I had my GitHub up on my resume. I don't even think one employer actually looked at it, but the fact that I went the extra mile to make one really impressed them. And also, people will see your work, collaborate, and they can offer you advice, and you'll really start to get better as a data scientist. So that about wraps this up. Stay tuned because my next semester of grad school is starting up, and I will be having a series every week that says what I learned in grad school this week. My curriculum for this semester is SQL, Tableau, and Python. 3 things that you guys will be very interested in. So stay tuned because I'll have basic intros to everything on a weekly basis. Thanks for watching this. Please like and subscribe, and good luck with your projects.